Problem having been chosen from the same book Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, calculate the energy needed to accelerate a spaceship of mass 10,000 kilogram to a speed of 0.3 c. Okay, 0.3 c implies or means approximately 30% of the speed of light. Okay, for intergalactic space exploration, compare this with a projected annual energy usage on Earth of 10 to power 21 joule. Okay, calculate the energy needed to accelerate a spaceship of mass 10,000 kg to a speed of 0.3 c for intergalactic space exploration. Compare this with a projected annual energy usage on Earth of 10 to power 20 joule. Dear students, now we are going to its solution, but before solution we are going to introduce several snapshots. Okay, these snapshots will tend to provide a foundation regarding solution of our problem. Within the guidelines provided by these snapshots, we will solve our problem. Okay, first snapshot is about Lorentz factor gamma. We have included the snapshot several times, so for the time being we skip its further explanation. Okay, second snapshot is about kinetic energy. Okay, relativistic expression for the kinetic energy. We have also used this snapshot several times in our previous problems, so we skip this also. Okay, dear students, next thing after this snapshot, a conversion factor has been shown. Okay, what conversion factor? Conversion factor actually derived units of joule have been shown or explained, described. Okay, 1 joule is equal to 1 kilogram meter square per second square. Okay, this conversion factor will also be used in our solution. Okay, now only these two snapshots and one conversion factor. Now we are going to solve our problem in a formal manner. Okay, first of all we come towards the Lorentz factor. Okay, we know that Lorentz factor gamma is equal to 1 over 1 minus u square over c square, where c is the speed of light, 3.0 into 10 to power 8 meter per second. But for the purpose of determining Lorentz factor gamma, we do not need to put this value, that is 3.0 into 10 to power 8 meter per second. Okay, because our u is given in terms of c, that is 0.3 c, that is to say about 30% of the speed of light. So we will not use value of speed of light in terms of meter per second. Okay, we will keep c as it is. Okay, because c will be cancelled with c. Okay, Lorentz factor next step becomes equal to 1 over 1 minus 0.09. Okay, dear students, here c square will be cancelled with c square, and square of 0.3 is 0.09. Okay, so when 0.09 will be subtracted from 1, then it will become 0.91. Okay, and when under root of 0.91 will be taken, then it will become 0.95. Okay, and when 0.95 will be divided by 1, then it will become 1.05. Okay, so our Lorentz factor gamma has become equal to 1.05. Now we move further. Now we know that kinetic energy EK, where K is written as a subscript of E. Dear students, it is our just discretion. We can also write kinetic energy as KE, or we can also write kinetic energy as simply in wording KINETIC kinetic and ENERGY energy. Okay, this is just our discretion to denote it in this manner, where K is written as a subscript of E, that is to say energy kinetic or kinetic energy equal to gamma Lorentz factor minus 1 into mc square. Okay, we have found the value of gamma in previous step, which was 1.05. okay, minus 1 as in the expression, and mass is given in the statement as 10 to power 4 kilogram. Okay, it is given 10,000 kilogram, which is equivalent to 10 raised to the power 4 kilogram. Moreover, value of C is 3.0 into 10 raised to the power 8 meter per second, and here C is in square, so 3 will become 9 and 10 raised to the power 8 will become 10 raised to the power 16, and meter per second will become meter square per second square. Okay, now dear students, when we will subtract 1 from 1.05, then it will become simply 0.05. okay, so 0.05 into 9 into 10 raised to the power 20. Actually, dear students, this 10 raised to the power 16 is also plus, and this 10 raised to the power 4 is also plus. So both these will add, and our expression will take the form as 0.05 into 9 into 10 raised to the power 20 kilogram meter square per second square. And we know that this factor, this arrangement is equivalent to the derived units of joule or alternate units of joule. Okay, or perhaps it may be treated as a conversion factor. Okay, so we know that in place of this, that is kilogram meter square per second square, we can write joule. Okay, now in the next step, we have shifted decimal one step ahead. Okay, when we shift decimal one step ahead, then power of 10 will be reduced by 1. However, when we shift decimal one step backward, then power of 10 will be increased by 1. Okay, anyhow, it has become equal to 4.5 into 10 raised to the power 19 joule. Now, dear students, actually in statement it is given that 10 raised to the power 21 joule. We have to compare it with 10 raised to the power 21 joule. We move to statement. Okay, statement is that compare this with a projected annual energy usage on Earth of 10 raised to the power 21 joule. 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 So, dear students, 10 raised to the power 19 and 10 raised to the power 21, there is difference of 100. Okay, so we will arrange this setup in a sense that our result becomes 4.5% of this. Okay, because this quantity is 100 times greater than this quantity, and given quantity is this, that we have to compare it with this. So we will conclude our result in wording that it is 4.5% of this given part. Okay, and now this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.